times, that means 100 times summation xy. So it's okay, these are big values, I'm sorry for that, but it is what it is. So 225504.3. So n times xy minus summation x times summation y. That means this value times this value. So minus, sorry, minus 2555.31 times 7858.859. So the numerator is done. So divided by the denominator. So look, for denominator there are two terms, this term, and this term. So let me do the first one. It's n times summation x square. So 100 times summation x square is 73469.23. n times summation x square minus, look at summation x whole square. That means summation x is 2555.31, and take the square of that, square it. So that's the first term, but we are not done. We have to take the square root of the whole thing. So to the power 0.5. This guy times just a similar guy for y. So n times summation y square. So 100 times 693,655.3 minus summation y whole square. That means 7858.859, and then square it. And that's the second term, but we are not done. We have to take the square root of that. So to the power 0.5. And you get 0.99.02. I mean, it's close to the value we have here, 0.01. So that's okay. So for us, r equal to 0.9902. We got it. Similarly, another example. So look here, the direction is negative, and we have these 5 values here. Oh, by the way, so here also n equal to 100, and we have these values. So with these values, let's calculate r. So let's keep it here, and okay. So first the numerator, 100, that means n times summation xy. So times the negative value, so minus 3499.65. So n times xy minus summation x times summation y. Here you can see summation x times summation y. So that means this times this. So 18, sorry, minus 18.44 times summation y is 419.18. So that's the numerator is done. divided by, okay, once again two terms. The first term is, so two terms, I'm using multiple brackets. So this bracket is for the first term and this bracket is for together. So 100 times summation x squared, which is 911.52, minus summation x whole square, so 18.44 square. Now we are not done, we have to square root it. This guy times the second guy is n times summation y squared, so 17323.08 minus summation y whole square, so 419.18 square. And oh, sorry, we forgot to take the square root of this guy, so 0.5, and that gives us minus 0.9513. So yeah, here they got 1.4, I got 1.3, so R equals minus 0.9513. So, and there's the next example with similar things. Here R equals minus 0.0148. You can plug in these values and get it. Similarly here you can plug in these values, here n equal to 50 by the way, and get R equal to minus 0.7366. The formula is remains same, obviously. So that's how you calculate R, and you can see that R equals 0.9901 means direction is positive and it's strong, and yes, it is strong. Here minus 0.9514, so direction is negative because it's negative, but it's also strong, so it's strong, you can see. For this one, R is minus 0.0148, so that's like negative but weak. So I mean, you cannot even make out that this whole thing is negative. Like, it looks like a blob, but that's what you expect because this R is very close to 0. So it's because it's very close to 0, there is no linear trend. It looks like a blob. And on this one, you can see the direction is negative, but it's not so strong. So you see that thing, R equals minus 0.7366. So it's negative, but it's minus 0.73 is not close to minus 1 that much. It's good, but it's not that good. So I hope that gives you an idea about the power of R. Now the next question we should ask is, so how to actually fit a line through the data. That means, for example, let's take this height weight data. Let me copy it and paste it here. So that's our thing. So now how to actually put a line through it. Now I can put this line, my friend will come in and she can put this line, and maybe someone else will come and put this line. Somebody else comes and puts this line. So all of them are kind of okay. Maybe some of them are more okay. Maybe you want to say that this particular line looks more okay. Or maybe some of you want to say, no, this one looks more okay. So, I mean, how to actually fit a line? So that's my point. So we can't just like take a ruler and draw a line through it. That would be possible if all the points are in perfect one straight line, but they're not. They're haphazard. So how to actually draw a line? So we have to come to a mathematical decision for this, and the decision is called method of least square. And we will not right now, because we have short time, we will not go into details about this method. So remember, we just need a line y hat equals a plus bx. Why did I write y hat? That's because, I mean, I can write y equals a plus bx, but that's not really true, is it? I mean, the value of y is not exactly equal to a plus bx. So the estimated value of y is a plus bx. That means, for example, suppose I am taking this line, and for this line, for this point, suppose for this point, no, that's, sorry, I'm sorry for that. So for this point here, the actual value of y for this point is whatever this y value is. But what should be y hat? The y hat should be, you drop perpendicularly here, and this value of y is y hat. So this is actual value of y, this is y hat. That means the estimated value. So the actual value of y is never a plus bx, because the points don't fall on a straight line. But the estimated value is a plus bx. So what's the mathematical decision about what a and b should be? So there is a formula. The formula is like this. The formula is b equals r times sy by sx, and a equals y bar minus b times x bar. So we'll come to this step by step. So for example, I'm sorry for that. So what's this r? B equal to r times b equals r times sy by sx. So here r is, as we just learned, is correlation coefficient. What's sy and what's sx? Sy and sx are nothing new. These are our old friends. We already know them. This is sample standard deviation of y, and sx is sample standard deviation of x. I mean